Good morning all. We are the students of JBIT College, Triple Department, final year Triple B students, and we are from batch 1. I am batch coordinator Srimukhi. She is Madhavi, he is Agastya, and he is Vijay. Our project is maximum demand control and fault alerting for industries, and he will explain the rest of the project.
Start.
Good morning all. Now I am going to explain the project Maximum Demand Controller and Fault Alerting for the Industries. Basically, the equipment contains parts like regulator power supply, regulator power supply, energy meter, and optocoupler, relay, microcontroller, microprocessor, LCD screen like liquid crystal display, and these are the resetting buttons. This is the buzzer for buzzing the sound, and this is the bulb which is represented as a load supply.
Start.
Step 1, the regulator power supply is the basic first step of the equipment where the power supply is given, that is 230 volts, and this regulator power supply is divided into 3 parts. Primarily step down transformer which converts 230 volts into 12 volts and 5 volts, and this is the rectifier which rectifies the current from AC to DC, and this rectifier rectifies the AC to DC, and that DC is being purely converted into the DC by the capacitive filters. That capacitive filters has been given out to the supply as 5 volts to the microcontroller, and step down to 12 volts supply is given to the energy meter. From energy meter, the current is being supplied to the load supply by a switch acting, that is called relay, and another supply is given to the optocoupler which is used to the conversion of energy pulses to the digital pulses, and this optocoupler is being inserted to the A4 pin of the microcontroller, and this relay is being inserted to the C4 pin of the microcontroller. This is the supply part of the demand controller kit, and to read these readings, primarily we have set the load supply, we have given a setting button and selected as OK as the input maximum demand. These LCD pins are inserted to the slots of the microcontroller from B2 to B7 pins. And from this pins, the LCD screen pins are being allowed. From here, the buzzer pins are alerted to the C7 pin of the microcontroller. This is the connections given for the circuit, and now the functions of each component will be explained briefly. As I said, the regulator power supply is being divided into 4 parts. The step down transformer, which is being divided step down into the 2 parts, 12 volts and 5 volts. The 5 volt supply is given to the microcontroller, and 12 volt supply is given to the energy meter, and this energy meter pulses has been indicated by the optocoupler and LCDs. As I said, the readings are being taken by the optocoupler. These readings has been taken by infrared rays. The infrared rays which are came from the LED, light emitting diode. For 2 blinks which is done in the 1200 milliseconds, it denotes as 100 watts. If it takes 2400 milliseconds, then it can be taken as 500 volts. Has been given to the supply load from energy meter. And from optocoupler, the pulses has been taken from optocoupler, and this energy meter pulses has been converted to the digital pulses, which has been done by the connection given to the microcontroller. Here, this microcontroller, which is working as the conversion of the and this microcontroller which takes the signals from the optocoupler, and the code in it will be converted into the display which will be appeared in the LCD screen. And this LCD screen is inputted from B2 to B7 pins of the controller. Primarily we have to set a load which is up to 1000 volts. Now, as it is for a demonstration purpose, we are setting up to 300 volts, and for execution later we can see it. And after setting the button, which is only used for the increment, once for each button press only 10 volts can be increased, and after setting the respective voltage, click an OK button, which finalizes the amount of voltage we have been keeping as a maximum demand. And then after clicking the OK button, the load supply will be allow the current, power to flow from the energy meter to the load supply. Okay. In case of over voltage or over power supply, the relay isolates the circuit and sends the pulses to the microcontroller, and this microcontroller will display at which point or at which voltage the fault has been occurred, and it intimates the microcontroller to buzz the buzzer, and then the buzzer beeps a sound which alerts the people nearby the equipment or the circuit. Okay, up to now I have explained the components and its connections. Now let's execute the circuit. Primarily, as given the supply to the regulator power supply, and here we can see the welcome or set load, which I can set by pressing the button. For one press, I can see here 10 volts has been incremented. Now I am setting it till 230 volts. Pause. See, I am setting it for 230 volts. Now I am pressing OK button. As we can see, the reading has been given to the microcontroller, and microcontroller has given a free hand to the relay, and the supply is given from energy meter to load supply by relay. After to pulse reading in the energy meter, the optocoupler sends the reading to the microcontroller, and as digital pulses can be seen in the LCD screen. Okay, now we get reading as load has been taken as 169 volts. So there is no requirement for a maximum demand buzzing sound. So now to reset it, I am going to reset the button which is inserted in the controller. Now I have inserted. Till now we have seen that there is no required for the buzzing sound. Now if we set a demand which is lesser than the load supply, we can hear a buzzing sound. For sample, now I am giving a supply of 100 volts. Now here is a 100 volt supply, and now I am clicking OK. Now the pulses are being reading by the optocoupler and being given to the digital pulses to microcontroller, and we can see a load supply of 169. It shows as a heavy load and gives us the beep output from the buzzer. Thank you for the opportunities.